In 1859, a telegraph operator in Washington, D.C. received a shocking jolt of electricity from his machine, even though it was disconnected from its battery. The same night, auroras were visible as far south as Cuba and Hawaii. People could read newspapers outside at midnight by the light of the aurora. It was the most powerful solar storm in recorded history. And if it happened today, it would be a global catastrophe. That event is called the Carrington Event. And today we're talking about solar flares, coronal mass ejections, and space weather. What they are, how they work, and the very real question, could they take down modern civilization? Near sunspots, magnetic field lines become twisted and tangled as the solar surface churns. Tension builds, and eventually they snap. When magnetic field lines break and reconnect, they release an enormous burst of energy. That's a solar flare. The X-ray burst from a powerful flare can reach Earth in about 8 minutes, the same time it takes any light from the sun to reach us. Solar flares are classified by X-ray intensity. C-class are moderate, M-class are significant. X-class are the most powerful, a logarithmic scale where each letter is 10x the previous. The strongest flares ever recorded were labeled X28+ because instruments maxed out. Solar flares are dangerous, but they're not the main threat to Earth. That title belongs to coronal mass ejections, CMEs. A CME is a massive bubble of magnetized plasma, billions of tons of charged particles hurled into space at up to 3,000 kilometers per second. A CME aimed at Earth typically takes 1 to 3 days to arrive. That travel time is our warning window. When a powerful CME hits, it distorts the magnetosphere dramatically. Charged particles funnel along field lines toward the poles, creating auroras. This energy surge induces electric currents in long conducting objects, power lines, pipelines, cables. The bigger the conductor, the bigger the induced current. In September 1859, the most intense geomagnetic storm ever recorded hit Earth. Telegraph systems failed. Some operators received electric shocks. Equipment worked without batteries, powered by the storm itself. In 1859, the world ran on wood, coal, and copper wire. In 2026, it runs on interconnected power grids, GPS satellites, and internet infrastructure. A Carrington-scale event today would be a very different story. A 2013 Lloyd's of London report estimated such a storm could knock out power grids across North America and Europe for weeks to months. Not because the wires melt, but because high-voltage transformers get destroyed. They take 12 to 18 months to manufacture, and there aren't many spares. In 2012, a Carrington-scale CME erupted from the sun. It missed Earth by 9 days. 9 days. In 2022, SpaceX lost 40 Starlink satellites. A geomagnetic storm increased atmospheric drag, enough to pull them out of orbit before they reached operational altitude. Astronauts on the ISS must shelter in shielded sections during solar particle events. On a future Moon or Mars mission, solar radiation is one of the most serious safety challenges. During the May 2024 geomagnetic storm, the strongest in 20 years, auroras were visible across much of Europe, the US, and even parts of Australia. Billions of people who had never seen an aurora stepped outside and looked up. The sun gives us life, but it also reminds us from time to time that it is a star, and stars are powerful beyond any human scale. Space weather is one of those slow-moving risks that sounds like science fiction until it happens. The Carrington event did happen. Another one will happen. The question is whether we're ready. Next up, a journey to the very core of the sun. What's really happening 700 kilometers beneath that glowing surface? Leave a like if this raised your threat level appropriately. Did you see the 2024 auroras? Tell me in the comments. See you in the next one. Keep looking up.